Hi guys, here is a video for your long division with polynomials. So before we dive in, I just want to quickly go over some sort of standard, we'll take a trip back to elementary school long division before we get into this process here. So if I want to divide here 59 and 4, I'm looking for how many groups of 4 are in 59. So I just want to go through this process with you a few times. We'll talk about sort of what our result is, and then we'll be able to apply this for when we're dividing polynomials towards the end of this lesson. So the first thing I want to do is I want to look at this 4 and say how many 4s are in 5, and I know there's 1. So we'll zoom in a little here. So 1 times 4 is 4. I can subtract and get 1. I'll bring down my 9, right? I'm sure this is we're really throwing it back here, really kicking it old school. How many 4s are in 19? And I know, how many 4s are in 19? I know that there are 4 4s in 19. 4 times 4 is 16. Subtract, I'll get 3. So now I have a few options here. The first thing, now that I'm sort of out of numbers to bring down here, I know that 4 is not a factor of 59. I know that I can express my answer as 14 remainder 3. I can express my answer as 14 and 3/4, or I could keep going and I can add some zeros here. How many 4s are in 30? So my decimal and my decimal. How many 4s are in 30? There are 7. 7 times 4 is 28. Subtract, I'm left with 2. I can add another 0 here. How many 4s are in 20? There are 5. 5 times 4 is 20. I subtract and I'm left with 0 here. So my last way that I could express my answer is 14.75. For our purposes here, we'll express our answers this way. So we'll take our remainder and we'll put it over our divisor, which is the 4. So my remainder was 3 and my divisor was that 4. So that's how we'll express our answers moving forward here. Let's go ahead and do another example of long division. How many 5s are in 4? There are 0. How many 5s are in 45? I know there are 9. 9 times 5 is 45. Subtract, I'm left with 0. Ooh, I won't bring down a 0. I'll bring down a 6. How many 5s are in 6? There's 1. 1 times 5, so 1 times 5 is 5. Subtract, and I'm left with 1. I no longer have numbers to bring down here, so I know that my answer is 91 and 1/5. So my remainder of 1 gives me that 1/5. Let's just move forward onto this last one. How many 2s are in 5? There are 2. 2 times 2 is 4. Subtract, I'm left with 1. Bring down my 6. How many 2s are in 16? I know that's 8. 8 times 2 is 16. Subtract, I'm left with 0. Bring down my 4. How many 2s are in 4? There are 2. 2 times 2 is 4. Subtract, I'm left with 0. Bring down my 5. How many 2s are in 5? There are 2. 2 times 2 is 4. Subtract, I'm left with 1. And I no longer have any numbers to bring down. So again, I know that 2 is not a factor of 5,645. And my answer is 2,822, remainder 1, or 1/2. I also know here that 5 is not a divisor and is not a factor of 456. So there's just us sort of kicking it old school here and going over some long division problems. So what I'd like to do with you now, I'd like to keep working on some of these problems. And before we get into that, what I'd really like to do is recap some of these polynomial vocabulary words that we've been talking a little bit about. So we're just going to cruise through some of these problems here. So consider the following polynomial. How many terms does this polynomial have? Terms are separated by addition and subtraction. This polynomial has 1, 2, 3, 4 terms. What's the degree of this polynomial? The degree of the polynomial is the largest exponent, so I know that 3 is the degree of this polynomial. Awesome. Consider the following polynomial. What's the maximum number of possible roots? Knowing that the degree is 3, 3 tells us that's the maximum number of times that this could potentially cross the x-axis. So the maximum number of roots possible is 3. Is this polynomial in standard form? No way, it is not in standard form. Standard form of this polynomial would be starting with the term that holds my largest degree. So 2x cubed minus 5x squared plus 2x plus 20. So now I'm in standard form. My degrees go in decreasing order. Consider the following polynomial. What is its end behavior? So here I have an odd degree function with a positive lead coefficient. So I know that my graph will end up looking something like this. So as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. So there's my end behavior. What is the coefficient of its linear term? So linear is 1x here. So here I have x to the first power, and my coefficient there is 2. Just cruising through some of this vocab, guys. What is its constant term? The constant term is the term that is paired with no variable. So I'm looking at this 20 right here. 20 is the constant term of this polynomial. What is the lead coefficient? The lead coefficient of this polynomial is going to be the coefficient that is paired with the largest degree. So here I'm looking at this 2 right here. Now getting into a factored form polynomial, how many roots are possible? So I want to think to myself, how many times am I multiplying x together here? That's happening twice. So there are 2 possible roots of this polynomial. And seeing that this is in factored form, I know that x minus 4 is set equal to 0 and 2x plus 3 equals 0. If I plug in 0 for g of x, I know that I can actually tell you what the roots are. So x is equal to 4 and x is equal to negative 3 halves are going to be the roots of this polynomial right here. So what are the roots? It looks like we jumped the gun a little there, so that's great. So we already talked about what those roots are. So here's just a little intro for long division when we talk about dividing polynomials. We can use long division to help us find the roots or factors of a polynomial. So going back to when we did long division in the very beginning here, I knew that when I did 59 divided by 4, that my answer was not a whole number, it was not an integer, so I knew that 4 is not a factor of 59, okay? So I could use long division to help me find the factors of a polynomial. So looking at f of x is equal to x squared plus 4x minus 5, the roots of this function will be, I'll be able to tell you that when I factor this function. So I can factor this into x plus 5 and x minus 1. So what are the roots of this function? If I set each of these pieces equal to 0, I get that x is equal to negative 5 and positive 1. Those are the roots of this function. Okay, so moving forward, I can use long division to divide a polynomial by sort of a factor here. So what I want to do is I want to divide this polynomial by x minus 1, and I want to do it using long division. So again, dividing polynomials can help us find the roots, which is super helpful when we're graphing. when we're solving sort of a very standard equation, or when I'm trying to find sort of the landing point of a ball in a quadratic problem, or I'm trying to find a minimum or an end value. Okay, so they also have, the roots here also has lots of applications for us as well. So long division, the first thing that we need to do is we need to write the dividend in standard form. So this would be what we're dividing into. So my dividend here, I went ahead and wrote that in standard form. And it says here, be sure to include terms with coefficient of 0. So if I had something, for example, x to the 5th plus 2x squared plus 7, and I was trying to divide this by x minus 1, when I write it in standard form to include terms that have a coefficient of 0, I would write x to the 5th plus 0x to the 4th plus 0x cubed plus 2x squared plus 0x plus 7. So in order to divide here, I need sort of a placeholder for all of those values. That isn't the case for this problem that we're doing right here, but that's just something that I would like you to be aware of. So the next thing that I need to do is set up my long division, the same exact way that we do it with numerical values. So I have my x minus 1 on the outside over here, so I have my divisor, and then x squared plus 4x minus 5 is my dividend. And then I can go ahead and divide. And I'll do this just like I do this with my values. So x minus 1 into x squared plus 4x minus 5. So I'm just going to look at this first piece right here. So I want to think to myself, instead of saying how many groups of x are in x squared, I want to think to myself, what will I multiply this x by right here in order to get to x squared? And I'll multiply it by x. So x times x is x squared. And x times negative 1 is just going to give me negative 1x. So then what I want to do is I want to go ahead, and let's do this in another color so it's a little brighter. I want to subtract here. X squared minus x squared gives me 0, and 4x minus negative 1x is going to give me 5x. Okay? So now I want to say to myself, looking at this x again, what do I have to multiply x by in order to get to 5x? So I need to multiply that by 5. So I will add 5 up here. So 5, here we have my remainder. Oh, sorry guys, let's just back up one step here. Once we get this 5x after we subtract, don't forget we have to bring down the minus 5. So now I can go back, what do I need to multiply this x by in order to get to 5x? I need to multiply it by 5. So here we have 5 times x is going to give me 5x. And let's highlight in another color here. And 5 times negative 1 is going to get me negative 5. And I can subtract. And this is going to give me 0. So since I have nothing left, and I also have nothing else to sort of bring down over here, I know that x minus 1 is a factor of x squared plus 4x minus 5. And another factor of x squared plus 4x minus 5 is my result here, which is x plus 5. So I know that x minus 1 times x plus 5 is equal to x squared plus 4x minus 5. So x squared minus 1 is a factor. I have a remainder of 0 here. So we just did some long division, and we were able to figure out that x minus 1 is a factor, which means that 1 is a root, and here, looking at my result, negative 5 is also a root. So there's just one example of long division. Could we have factored this polynomial? Absolutely. We definitely could have factored this polynomial, but sometimes it's just a little easier to use smaller numbers to get an example out of the way. So we'll do this problem here, and we'll do one more, and then I'll let you practice some on your own. So division with polynomials. So let's see, is x minus 2 a factor of, this should say of, that's silly, sorry for the typo guys, of q of x. So I need to make sure that my dividend here is written in standard form and I have all my placeholders. I have x to the fourth, third, second, first, and then my constant. So let's go ahead and divide here. What do I need to multiply x by in order to get to 2x to the fourth? I need to multiply that by 2x cubed. 2x cubed times x is going to go ahead and give me 2x to the fourth, and 2x cubed times negative 2 is going to go ahead and give me negative 4x cubed. So I can subtract here. 2x to the fourth minus 2x to the fourth gives me that 0. Here I have 4x cubed minus negative 4x cubed. So that minus negative is actually going to have me add. So off to the side over here, we'll zoom in. I have 4x cubed minus negative 4x cubed. So that's going to give me a plus plus over here. So I have 8x cubed, and we'll get rid of this. So then I can bring down my minus 13x squared. What do I need to multiply this x by in order to get to 8x cubed? I need to multiply it by 8x squared. So 8x squared times x is 8x cubed, and 8x squared times negative 2 is going to give me minus 16x squared. So I can go ahead and subtract. I'm left with 0 over here. And then off to the side, I have negative 13x squared minus negative 16x squared. That gives me a plus plus, and I can see that I'm left with 3x squared. So I'll erase my sort of shorthand work off to the side, and now I can bring down my minus 5x. What do I need to multiply x by in order to get to 3x squared? I need to multiply it by 3x. 3x times x is 3x squared. 3x times negative 2 is going to give me negative 6x. So 3x squared minus 3x squared is my 0. I have negative 5x minus negative 6x. So here I'm left with 1x. I can bring down, we'll erase my scrap work over here. I can bring down my minus 3. So now what do I have to multiply x by in order to get to x? I can multiply that by 1. 1 times x is x, and 1 times negative 2 is negative 2. I can subtract here negative 3 minus negative 2, and that's going to leave me with negative 1. So my answer here, the way that I'll sort of tack my answer on in the end, my answer, I have a remainder of negative 1 over x minus 2. So just like when I had a remainder when we were dividing by my numbers, that I stuck it back over my divisor. Here, I can add on my remainder, and I can call it negative 1 over x minus 2. So when asking the question, is x minus 2 a factor of q of x? It is not, because we have this remainder here. It does not go in evenly, if you want to say. Okay? All right, last question. Is x minus 2 a factor of h of x? So here's my h of x. We'll set up and divide. I have all my placeholders in here. I'm just going to go through this one quickly since we've done this a few times. X into 6x cubed. I need to multiply that by 6x squared. It's going to give me 6x cubed minus 12x squared. I can subtract, and I'm left with negative 7x. I can go ahead and bring down my negative 7x squared. I can bring down my positive 16x times what is going to get me to negative 7x squared. That's going to be negative 7x. I have negative 7x squared plus 14x. When I bring down my 16 here, there's also an x. I can subtract. That's going to give me 0 here, and I'm left with 2x. I'll bring down my minus 4. X times what is 2x? I can add 2 here. 2 times x is 2x. 2 times negative 2 is negative 4. Subtract, and here I'm left with 0. So I know a few things here. I know that x minus 2 is indeed a factor of this polynomial. I also know that x minus 2 times 6x squared minus 7x plus 2 is going to equal 6x cubed minus 19x squared plus 16x minus 4. I also know that one of the roots or x-intercepts of this polynomial right here is going to be when x is equal to 2. So that is all for our examples for dividing polynomials using long division. We'll cover synthetic division in the next lesson, but you do have a few problems to work on for homework, and the homework is a sheet that you can work on, and it's linked in Canvas. So please reach out if you have any questions. Other than that, I hope that you're enjoying moving forward with the course.